Welcome, fellow developers. In your quest to develop cutting-edge applications, you might find yourself looking for a comprehensive profiling tool that can be used across a variety of target devices. Qualcomm Profiler is a performance profiling system that can be used to measure and optimize application scaling across Qualcomm system on chips, or SoCs, CPUs, GPUs, DSPs, and other IP blocks. My name is Jessica Benson, a project engineer at Qualcomm. In my current role, I focus on the commercialization and deployment of Qualcomm's newest tools, including the Qualcomm Profiler. I'm going to guide you through the installation of Qualcomm Profiler and show you how your application's performance and data can be extracted using the command line interface, or how to visualize it using the graphical user interface. Qualcomm Profiler provides a comprehensive systems view and enables you to profile and identify performance bottlenecks on multiple targets, including Android, automotive running QNX, and Windows-based devices with ARM64-based processors. Supported hosts include Linux and Windows, and profiling can be accomplished directly on the target or remotely via TCP/IP connection over the network. Qualcomm Profiler has 3 key features that make it uniquely beneficial as a profiling tool. First, Qualcomm Profiler comes with the ability to execute on or off the target device via the command line interface. This allows you to develop high-level automation solutions. Additionally, Qualcomm Profiler comes with APIs that enable you to create custom profiling use cases embedded in your applications. Automation APIs are available both on the target as well as connected to the host via TCP/IP. Another notable feature of the Qualcomm Profiler is that it provides a rich user experience with an intuitive interface that enables you to configure and observe profiling information visually. Qualcomm Profiler is available via the Qualcomm Package Manager, and I will walk you through the installation of both the Qualcomm Package Manager and the Qualcomm Profiler. Another tool with a similar name but different functionality is the Snapdragon Profiler. Snapdragon Profiler primarily allows you to get rich data on GPU-specific metrics. So you can start with the Qualcomm Profiler for a comprehensive profiling, and depending on your use case, you could take a deeper dive and a refined view with the Snapdragon Profiler. Now that you know what the Qualcomm Profiler is, let's get started using the tool. Getting started with the Qualcomm Profiler can be done with 3 simple steps. Install the Qualcomm Package Manager 3 desktop application, install Qualcomm Profiler, set up the device. Install the Qualcomm Package Manager 3 desktop application from the Qualcomm Package Manager web portal at the link on the screen. Open the Tools page and search for QPM3. Select the latest version and click Install. Once you have launched and signed in to the QPM3 desktop application, search for Qualcomm Profiler. Select the latest version and click Install. For Windows on Snapdragon, Qualcomm Profiler must be installed directly on the Windows on Snapdragon device and run locally. The next step is to configure your device depending on your target OS. For each external device, execute the installation script for your connected target device. After the installation is complete, you can use the command line interface or graphical user interface. We will review each in the following section. The installation location includes some important documentation files, one of which is a PDF with information about each supported command and the supported metrics, which we will come back to later. First, I will show you how data can be extracted using the command line interface, or CLI. For the device with Windows on Snapdragon, you can run on the device without the need to connect from a host. With the help command, you can display the list of supported commands. Now we can check what capabilities are available for the device using the capabilities command. We can see each of the available capabilities we can profile. And for each capability, we can see the list of available metrics, each of which have more detailed description in the documentation, the streaming rate supported, that is the rate at which the data is streamed to the client in milliseconds, and the sampling rate supported. This is the rate at which the data is sampled from the device in milliseconds. First, let's look at an example of profiling DDR metrics. We can use the profiling command with profile type as async, the capabilities name as listed earlier, profile time in seconds as 20 seconds, streaming rate in milliseconds as 500 milliseconds, sampling rate in milliseconds as 40 milliseconds, and the live option to output data to the terminal. If we want to see the GPU BW information, we would select the metric IDs 5632 and 5635. For now, we select 5635 to show the effect of how an arbitrary application can affect the values we are profiling. We are loading an application to show how the GPU values increase as the application adds more objects. As you can see, the values go up as the amount of rendered objects go up. And come back down as the workload goes down. Each value includes the timestamps in hours, minutes, seconds, and milliseconds, the associated metric ID, the corresponding metric name, the value, the unit, and in this case, a friendly name for the metric. Another metric available for this device is 5638, or NSP data, used for profiling effects of intensive mathematical calculations. And if we run another arbitrary application, we can see the values start to increase and decrease once the application is terminated. You can also profile multiple capabilities at a time, say CPU, CDSP, and thermal. As you can see, each value has a timestamp, metric ID, metric name, value, and unit. But the parameter afterwards can change. For CPU, it is the core ID, for instance, while CDSP includes instant average value and session average value. And thermal includes zone name. At the end of each command, you are provided with a path to a file containing the data from the last session. By default, the file is in JSON verbose format, result format verbose. But we can also select CSV format for a comma-separated file, or trace format for a file that can be used in the industry standard Perfetto format. Now you can view the trace file in the Qualcomm Profiler GUI by opening the file. Or you can view it in Perfetto, which is a production-grade, open-source stack for system profiling and trace analysis. You have seen how data can be extracted using the command line interface. Now we will turn our attention to using the graphical user interface to view the data, and later we will walk through the example of viewing DDR metrics in the GUI. You can start the GUI by navigating to the appropriate folder on your machine to start the executable, or using a Windows shortcut. On devices with Windows on Snapdragon, the GUI executable is located at this location. We will open the GUI using the Qualcomm Profiler shortcut for ARM64-based devices. Note that there may be pop-ups to allow permission for running GUI executables and Node.js runtime environment when opening for the first time. You can click Allow. Once the executable starts, it will open up the main screen. For first-time use, there is a shortcut pop-up card that appears that introduces the following main options: open a workspace, connect to a device, and analyze existing data. These options are shortcuts to different pages in the application's main workflow. We'll go ahead and dismiss this pop-up, and we'll touch on each of these pages shortly. We are now on the home page of the application, which allows users to reach any of the other main pages by clicking on the options in the top-level toolbar. On the left side, under the Welcome section of the home page, There are also shortcut options, which are available on other pages for workspaces, devices, and data analytics. You can opt to be redirected to the workflows available on other pages by clicking on these options. These options will be touched upon in their respective pages. Underneath these options are the FAQ section. You can click on any of these options to open up documentation in the application with information on the Qualcomm Profiler GUI and its use cases. In the middle of the home page, you'll see a section for workspaces, devices, and recent data files. Underneath these sections, there are recent entries, if any, for each section. These entries are cached locally in a configuration file that allows users ease of reuse for saved configurations. Clicking on these entries should either open a saved workspace, connect to a saved device, or show a recent data file. If you want to clear these entries from the application cache, you can either do so in the GUI with the respective clear option, or by deleting the configuration file stored on the system at this location. Note that clearing these workspaces entries won't delete the workspace files on the local file system. You will still be able to open the workspace file, which we'll touch upon in the workspaces section. We'll now look at the workspaces, which are meant to represent configurations that can be easily saved and reused. You can save multiple workspaces with or without device configurations, as well as selected capabilities and metrics for profiling. This will offer ease of reuse for profiling needs as desired. You can reach the Workspaces page by clicking on the Workspaces tab available on the home page. On the Workspace page, you have several options for workspaces, as well as recent cards of saved workspaces on the host machine, if any. Clicking on any of the workspace cards will load a saved workspace and its configurations. Selecting the Open Workspace option will open the File Explorer and allow you to select a workspace file saved on the machine and load it into your application. Selecting the Create Workspace option will open the application to a step workflow where you can create and save your own workspace to the host machine. You will have to specify the existing device to save, or alternatively, create a new one, or go through the rest of the configurations. Once the configurations are set, you can select Save Workspace, and the workspace file will be saved locally to your machine to be reloaded into the application as you may need in the future. You can reach the Devices page by clicking on the Devices tab available in the toolbar. On the Devices page, you have an option to add a device or select any of the recent devices to load onto the application. Selecting the Add Device option will open a pop-up that allows you to specify a name and platform type for the device you wish to connect to. Once these fields have been filled, selecting the Connect button will take you to the connection configuration page for profiling. It's important to note that because you're on a device with Windows on Snapdragon, pressing the Connect button will establish a local host connection for profiling purposes, and then immediately transition to profiling configuration. If this were not a device with Windows on Snapdragon, after pressing the Connect button, it would transition to a page to configure the IP address or port number to establish a TCP connection. Once you have configured a device and a connection has been successfully established, the application will be on a page for profiling configuration. There are several options available on this page for you. It's important to note that there is now a left side navigation bar present, which is shown on the application when you successfully establish a connection with a device. You are currently on the Device section, which is the page that allows you to configure options for profiling. The other left navigation bar option will be addressed in a bit. Similar to the Create Workspace workflow, you can select Save Workspace option to save the current configuration to the host system, which allows you to quickly connect this same setup with ease by loading in this saved workspace file. If desired, you can also choose to close this current workspace. This will not clear the workspace file from the system or delete it from the application's saved cache. This acts as a way for you to start from a fresh workspace setup in the same session of this application. You can now configure capabilities and metrics desired for profiling purposes. The GUI will display the capabilities of the system. The capabilities are auto-detected from the system and provide you with the capabilities available for profiling. Within the selected capabilities, there are a set of metrics associated with those capabilities. You can select a subset of metrics within a given capability to capture data for those metrics during profiling. For the purpose of this demonstration, we will select the following capabilities and metrics. Select the DDR capabilities, which auto-selects the first metric, GPU BW at DDR, and select the NSP BW at DDR metrics for profiling. You are also able to configure the profiling options with the Profile Settings window by selecting the Profile Settings option in the bar. You can configure options such as delay profiling, profiling duration, and streaming rate. By default, the application also selects the Save to File option, which will save .hdf file for profiling data received so you can view it in the application later. You may also select or deselect the Save to CSV option, which will also save the profiling data to a CSV file format on each profiling session. For this demo, we will check the Save to CSV option and set the profiling duration to 2 minutes. Once the capabilities and profile setting configurations are complete, you will press the Start Profiling button on the top right corner of the screen and begin profiling the system. You will see a graph of chosen metrics shown on the screen, as well as data associated with the metrics at the bottom of the screen. You will see the effect of your profiling charts as we run the same application we used in our CLI portion to test these two metrics. For GPU BW at DDR, you will see the effect of the same OpenGL Aquarium sample on profiling the GPU DDR. As you can see, the value goes up as the amount of rendered objects goes up. And come back down as the workload goes down. For NSP BW at DDR, using the same CLI stress app, you can see the value of NSP starts to increase. And decrease once the application is terminated. You can also choose to press the Stop Profiling button in case you would like to stop the profiling before the pre-selected time has expired. Once the profiling is done, you can continually transition back to the device page to choose different combination of capabilities and metrics for profiling purposes. Using the left navigation bar, you can also select the Profile View option on the left to see the graph and table data of your recent profile, as well as the data file to see the recently saved files of your profiling session. In each entry for the table in Data Files section, you can select the folder icon, which opens a file explorer for this file's location. The eye icon, which will load the data stored in that file into the application view for analytics, or the spreadsheet icon, which will load the corresponding CSV file if the Save to CSV option was selected in Profile Setting. You can also opt to open a different data file aside from the ones in this table by opening the Data Analytics page. You can reach the Data Analytics page by selecting the Data Analytics option in the toolbar. On this page, you have the option to open a file or select one of the files in the recent tables. Clicking the Open File option will open a file explorer where you can select a file on the host machine to open in your application. You are able to select different file types to be loaded into your application. You could choose to open a .hdf or a .csv file that was saved to your system from a previous profiling session. Note that the GUI places these saved files in this location. You could choose to open a .json file that is typically collected through the CLI and is Perfetto compliant. Other file types that you could view inside the GUI include Excel files, and flame graph SVG files. Now that you have seen how to extract and visualize data using the Qualcomm Profiler, I am certain you will find it useful in your application development workflow. As thousands of developers have already discovered, this tool can help you identify metrics needed to optimize your application and significantly improve the user experience. Please visit the link on the screen to find other useful tools for application development.